Thank you very much for a wonderful morning, those of you who are on the panel, and for the audience. I hope it was as instructive for you as it was for me. It was a fascinating, I think what Bob Metcalf called it, a nerd out, which was spot on, I think. Okay, so we're going to be talking much more about the status of Ethernet today, this afternoon, and where it's going in the future. So I'd like to invite Rohit Mehra to come up and from IDC to come up and with his panel, please, to start talking about that very thing. Rohit Mehra, where are you? Here he comes. Big hand, please.
Thank you so much. Great, welcome. I hope everybody had a good lunch. Are you still awake? Okay, good. Good to know. Normally, if the lunch is too good, then don't have much of an attendance. Good afternoon, and welcome to the first afternoon session this afternoon, this very important period in the phase of Ethernet, having covered 40 years of Ethernet. My job this afternoon really is to bring to you a really esteemed and I would say powerful panel of speakers from the networking industry, specifically from the Ethernet networking industry, and you'll hear from them in a minute. Let me first start by quickly introducing the panelists, and let me get to the right slide. All right, so if you don't, folks wouldn't mind, just raise your hand when I introduce you. So Mike Banic, VP Marketing with HP Networking. Mike, welcome.
Thank you.
Steve Collen, VP Enterprise Marketing with Juniper Networks. Welcome, Steve.
Thank you.
Sachin Gupta, Senior Director, Enterprise Networking, Cisco. Welcome, Sachin. And Arpit Joshipura, VP Product Management and Marketing, Dell Networking. We know, Arpit, that you come from Force 10. You've had senior product management and marketing roles. Welcome.
Thanks.
So without further ado, I know we have a very short capsule of a window to get our message out in terms of where Ethernet fits within enterprise networking, so I'll just get started. I'll spend just a few minutes providing my perspective on the Ethernet market itself and where it's come from and where it's going, and then we'll get right into the panel. And at the end, like some of the other sessions, we'll try and keep some time for you for audience Q&A, just to make it interesting, just in case these folks have not provided you with enough of a debate, enough fodder, if you will, for you to make this interesting. So very quickly, where is Ethernet today? If you see the Ethernet market, the broader enterprise market in 2013 is at $42.4 billion per IDC's forecast. And that includes all enterprise networking technologies combined. And you can see from this slide on the right, the table tells you what are the various technologies that are included with enterprise networking. The key aspect of this that I do want to point out is Ethernet is a core technology for each one of these enterprise networking technologies. So much so that it garners nearly 47% share of the broader worldwide networking market. In fact, some of the other adjacent technologies, you might even consider them really layered on top of Ethernet. For example, wireless LAN. We all look and live our lives with Wi-Fi today, with certainly rides on top of Ethernet. I would call it sister technology. But nevertheless, the point is that Ethernet is a core technology. Just layer 2, 3 Ethernet is a core technology in almost all enterprise shops today. Having looked at 2013, I want to actually walk you through a little bit of memory lane. I don't have 40 years of history here, but I do want to share with you. I think we got data from 1995, so surprising that we still got it. This is end user spending on Ethernet from 1995 to date to 2013. You'll see this market has grown in terms of users, end users and IT managers, network managers, spending on that infrastructure and how that market has grown. You'll see a few bumps along the way, but generally it's been a great ride for the last 25 years or so that we've been able to measure it. The next part I want to talk about is look at Ethernet by speed. I thought you might find this data very interesting as well. The red line is gigabit Ethernet that we all know that's been, the backbone of the enterprise networks, especially larger enterprise networks for many years. And that market, again, you see a little bit of a bump in 2009, largely macroeconomic issues, but it stayed, held its course. The blue line going up all the way is 10 gig. No question that 10 gig will actually, we expect at IDC that it'll take over by 2016. Actually, that'll be a market size larger than gigabit Ethernet. And you also see at the bottom right, 40 gig as well, ramping up literally like a hockey stick. So that's as far as the speeds and feeds. I also wanted to segment the market for you in terms of data center versus non-data center. So the yellow line is data center. No question, we know that's the hot growing market for Ethernet, and largely driven by 10 gig and 40 gig of late, growing very, very fast. The one in red, though, is campus Ethernet, largely. There's a little bit of service provider, but I really wanted to segment data center versus non. So actually, yeah, it's a relatively flatter line, but significantly higher market than the data center market. So I know many of us focus these days on, and especially many industry analysts like myself, and we drink our own Kool-Aid and say it's the data center to focus on, but let's not forget the campus. The next piece that I want to talk about really is what's happening with network workloads. At the end of the day, they will determine where we find value in Ethernet. And I've got a long laundry list here. I don't want to go into each one of these, but I want to basically share that these are some of the workloads that we see end users and IT managers being most concerned about. Some are concerned more about videos, some might be concerned about the virtual desktop, others might be concerned more about security, but at the end of the day, they are thinking in terms of the network, specifically the layer 2-3 network, and finding ways to evangelize and make it work for the needs of the business. The linkage between your business applications and the Ethernet network has never been greater. And that's what is driving what's happening today. So without further ado, let me move to the topics for discussion that we as a panel will walk through over the next 20 minutes. So are you guys ready for some rapid fire questions, guys?
Sure. Absolutely. Sure.
Great. Looking forward to it. And I'm sure the audience can't wait to get your views on some of these. So I have the honor of having picked some of the topics. The speakers had not seen these before. I will vouch for that. I thought some of these topics were going to be of primary interest to many of us, looking at where are we today with Ethernet in the enterprise and where are we going. So we'll try and address it to some extent where we are today, status quo, but really where we are going. So let me start first with the mobile edge. We know BYOD has been a hot topic in the last few years. So where exactly do the lines of mobility and Ethernet, your wired network, where do they intersect and where is that going? Who wants to start? Okay, Steve.
I'll say that they intersect at the management layer. So I think the key criteria moving forwards is a management platform that can handle both wired and wireless infrastructures. That single pane of glass will be a definer in the marketplace. Now, I think it's interesting to consider, however, who will provide that management interface. Will it be vendors like us, or will it be cloud-based provided by some other kind of service provider?
Right, Mike.
So, one of the things I want to touch on is, first of all, HP provides multi-vendor management for a lot of customers in the enterprise space. And we do that with products that come out of HP software. But we also provide a lot of reach management for the network for our own products. And that includes a lot of third-party vendor products. And one of the things we've learned about BYOD is you can solve a lot of problems for customers quite easily in the network. I agree with Steve. The intersection point is at the management plane, because things like BYOD and mobility isn't just about the smartphone or the tablet, but also about the laptop. So providing that single consistent policy enforcement based on the identity of the user, regardless of how they connect and wherever they go, is important. And sorting out problems that could, right now only be solved with things like mobile device management in that single pane of glass can bring about a great economic benefit. It brings about simplification, and that's really the core of our strategy at HP.
All right, Arpit.
Yeah, so I think the problem or the question you framed was, BYOD and how should we look at it, right? So we look at it from three perspectives, right? The D part of it, like the devices first, right? And I agree with Mark, there's not just phones, it's tablets and anything that you can bring. And not only that, it's moving to, VDIs and thin clients, and, you got to manage the entire inventory of what anybody brings, right? So that's sort of the first problem to be solved. The second problem to be solved is not only is there multiplicity of devices, but there is the throughput going up per device, right? So with the 802.1 AC, 11 AC coming later this year and a gig to a desktop, the access of the enterprise or the desktop or the device is probably gig, right? Which means, there's a gig of throughput coming in, and then, depending on the oversubscription and all that, you got the campus core, right? So that's the second problem. And I think the third one, which is the architecture. How do you fit it all together? So I agree that there is a management intersection, but I don't agree that we have solved the problem as an industry. Wireless networks are still an overlay. On the Ethernet, yes, bits will be transported at the fastest, lowest cost, hit the ground as soon as possible, but we've not solved it. Okay.
So if I can just add to that. So I think management is critical, but I don't agree that wireless is still an overlay. So I think you have to treat, if the mobile edge is real, you have to offer the same experience over wired and wireless. So treating it as an overlay just does not work, especially with 11AC now shipping from Cisco and providing gigabit access over a wireless network. You have to terminate wireless at that first switch. You have to think about quality of service. When we brought voice to the network, we thought about resiliency with PoE. We thought about quality of service. If you're going to move to a mobile edge, yes, you need unified access. You need one management. You need one policy across wired and wireless. You also need to have one network that can deliver all the QoS control and security that you're expecting to offer that consistent user experience.
I happen to know these speakers personally as well, and I have to admit, I was wondering before we started the panel, would they be ever in a position to debate? But as you can see, there's some healthy debate going on here. Glad to see that. All right, so we've talked about the mobile edge. In the interest of time, let's look at the opposite end of the spectrum, if you will. Let's talk about the data center. Where are we with Ethernet in the data center today? And what problems have we addressed? And what are some of the frontiers from a data center and Ethernet standpoint? I think, Arpit, you're raring to go.
I can go. So I think data center architectures historically have been set up based on older workloads that were predictable, okay? Exchange, SAP, whatever. The IT admin knew exactly how to architect the data center. The newer workloads, right? The web workloads with Memcache or, storage replications, VDI, Hadoop, you name it, right? They're unpredictable, specifically around, even VMs and VMs moving around and server virtualization. When you don't have a predictable workload in a data center, your architecture needs to be flexible. And I think this is what is the heart of the problem today, where instead of, if I need to go to a person next to me in a hotel room on the same floor, why go down to the receptionist to find out he's on the same floor? That's what today's architecture is. You're going all the way to the core, aggregating versus distributing your switching and networking close to the VMs into as close to the servers as possible. So I think this is where it's heading. And then, of course, we'll all agree 30 gig, 10 gig, all those things, I don't think we need to debate that, right? I think we'll all agree.
Are you saying it's the capacity and the performance issues are taken for granted?
Taken for granted. Latency, performance, throughput, that's a given.
Okay, who wants to take him on?
I want to take a completely different take on this, which is today the administrative expense in networking is really high. It's much higher than the cost of acquiring the actual infrastructure because it's all done by people, right? And just like there's Metcalfe's law, there's also Moore's law, right? And we know that computers and everything else is going to get twice as fast and cost half as much in the future. But the people who are doing all the administrative work, well, they're going to have a salary, and it goes up with inflation every year. But if we can automate things, we actually eliminate a lot of that. And there's some pretty cool stuff that we've actually demonstrated and we've filed patents on that do that today. And they do that for traditional network kit. And sometimes it doesn't have to be HPs, which ensures our customers have choice and flexibility. So this technology, virtual application networks, allows you to then start treating the network as though it's a set of pooled resources. You define what you need for an application, and it will automate the configuration of those resources. Access switches, core switches, routers, firewalls, IPSs. And it'll actually evaluate whether those services are there in place before you hit the go button to deploy them, so that you know that the reliability is there, that you can actually get the amount of bandwidth you need from the access layer, from the core layer. You can get the firewall services you need, and it takes that human middleware out. Our technology services people who stand up instances of Exchange for clients around the world all the time tell us to just deploy Exchange, very, very basic instance of Exchange, minimum 2 weeks. That's the time, the human middleware factor. That's very concrete. They've taken this technology and they've filed patents because they have seen it go to 5 minutes and deprovisioning in 7 minutes. And that's an innovation on top of Ethernet that will give great value to customers.
Steve, what's Juniper's view on where's the data center going vis-a-vis Ethernet?
Well, I'm going to disagree with both of the other speakers. Actually, I'm not, but I felt like I had to say that. So I think that we are in the middle of a war of bandwidth, density, and scale. And that war shows no signs of decreasing. I think, however, that the war will be won, again, at the management layer. Now, we see many claims of huge network scale, hundreds and thousands of servers. But the key question for me is actually how you make those deployable in a way that's easy to use, easy to manage, easy to deploy for the customer. So that, for me, is really where the war is being fought. Now, I did like the recent announcement from HP showing how they reduce from hours to minutes the configuration task by moving from the CLI to automated configuration. So that's good. The CLI is not an easy interface to use, and so I applaud that move. So the war will be fought on and that was a joke, the war will be fought on the management layer.
All right, Sachin.
So I agree the management layer is important, but there's innovations at just the Ethernet level that have been critical. And it is not a one-size-fits-all. So we find in a data center, you have low latency requirements for high-frequency trading. And if you innovate in silicon, like we have at Cisco, we're able to bring that down to a couple of hundred nanoseconds in terms of our capability to forward. If you think about creating overlay networks, you can innovate with OTV technology to create overlays, stitched together data centers. You can provide location independence with Lisp to make sure that the VM mobility that was being referred to before can be simplified. So we find that, yes, speeds and feeds will take their course depending on cost and power, probably two of the bigger drivers, but there's additional innovation that can be brought to the table to enable some of the trends that we're seeing in the data center.
Excellent. Well put, guys. Really appreciate your candid comments. Let me now, we've talked about two silos, both ends of the spectrum, the mobile edge in the enterprise network, and we've talked about what's happening at the core and the data center. Let me throw a little bit of a curveball and talk about a topic that's near and dear to many of us in the industry called virtualization. Very open-ended word, and I purposely have brought it into this discussion because there are differing views on how virtualization will impact networking. It has impacted servers, the compute function. It has impacted the storage world as well. And as you can see it, we live in a world where IT talks about desktop virtualization. They talk about application virtualization, and we live in a mobile world. You want to virtualize as much as you can because the power of compute in your hand is so great that you want to be thinking about it in a virtualized manner. All right, so now we've talked about how virtualization will impact networking. Let me ask the panel, what do you think of how virtualization sort of intersects with networking, intersects with Ethernet, and where do we go from here? Who wants to start? All right, Mike.
Everyone needs to take a turn at starting, right? So there's a couple things that Bob said early this morning that kind of made me think about things we're doing at HP that are very relevant to virtualization and requirements we see customers setting. One thing he said earlier today was about solving the problem of the rat's nest, and he also said the rat's nest is back. And it's kind of interesting that he said that because I kind of agree. And in the data center, one of the things we've seen with virtualization is it's actually caused all this additional network connectivity to servers because they're supporting all these different workloads. And we separated workloads in the past through physical air gaps. And so everybody wants their own port on the server, and that becomes untenable at a certain point. So actually dissolving network technology into compute allows you to have single big pipes that you then virtualize. You carve out channels that have that true separation, a true air gap, but virtually. And that eliminates a lot of the rat's nest. You get one cable that that server supports different workloads in the future. You don't have to rewire it. You just reconfigure it through software. So we do that with Virtual Connect Flex Fabric. And the other thing I'm seeing is, just the virtualization has this new drive on traffic patterns. And, one of the things that Rohit's been saying is, the evidence says that, a huge percentage of the communication is actually machine to machine. And so I think that Arpit made that point that, why go to the front desk when you just know, when you know what room to go to? Just take a direct trip to that floor in the hotel. So, this notion of traffic is east to west rather than north to south, and doing things to eliminate that latency by making a single big fabric that's layer 2 is, two things that virtualization's had as an impact on networking.
All right, Steve, you want to?
Sure. So to cut a long story short, the network has been getting in the way of virtualization. So we have to make the network invisible. That's certainly an interesting concept. But I think even more interesting is how virtualization is affecting the purchasing behavior and the decision-making group inside the data center. The networking team is in danger of becoming irrelevant. All of those Cisco CCIEs, their jobs are at risk. So we have to really, as networking vendors, make the network relevant again, but at the same time making it invisible, and at the same time as that, make it something that this new and emerging DevOps team actually cares about. So it's a multifaceted problem that we as a group have to address.
Okay, Sachin?
So I actually think the CCIE's, that career path is flourishing. I'm a CCIE myself. So now, with virtualization, you have to understand there's multiple phases to virtualization. We've touched on some of the aspects in data center. Again, this is an opportunity to innovate. Right? So if you've got virtualization happening in the campus, you can think about how you segment user groups. You can think about how you carry the rich context that BYOD provides at the access switch and use some sort of group tagging mechanism to create that to the network. You can think about virtual desktops and how the traffic patterns change for that. How do you insert real-time media and allow voice and video collaboration with virtual desktops to actually work? And again, in the data center, through innovations where we can provide location independence, we can provide overlay networks and virtualization through that, we can innovate so that we allow consolidation and provide simplicity with virtualization with its multiple phases.
Yeah, so I think my view is slightly different here, which is whether CCI is relevant or not, whether CLI is the way of future or not, that's TBD. I think the most important thing is the requirements on networks just got even harder, okay? With all the virtualization, based on some of our modeling, we're getting to 25x today's bandwidth per rack, okay? So someone's got to switch and route and forward that traffic, okay? So it's a big problem. Secondly, as I said, east-west traffic, server to server, all these new workloads, right? Tremendous amount of traffic. And architecturally, I don't want to go up and build new networks based on old thinking of, core and aggregation and top of rack and blade and, servers and storage and, things like that. As an admin, I want to look at newer technologies that push switching, down to servers, put it close to workloads, optimize the architecture for the specific workloads. A whole brand new set of technologies and switching is available. And by the way, they're all being presented in a server language, okay? GUI, point and click, Perl Python scripting. I was excited that Bob's taking that course or someone. It's just not. It's not a CLI world anymore. Let's face it, right?
Okay.
But the role of network does not diminish, right?
Great. Thank you for your insights. I also have to commend the panel. We've gone about 20, 25 minutes, and no one yet has uttered the word SDN. Believe it or not. That's great. Thank
tomorrow.
you. We've reserved that for tomorrow, and we agreed as a panel in our prep meet that, okay, we're going to make sure we. So since we are not talking about SDN, let's talk about network virtualization. All right? Let me throw this out to you guys.
Getting really close there.
We're close.
Borderline.
We're playing with words here. I've seen incarnations of solutions that IT is looking at. Some of it, us call it as network as a service. You can use different folks use different jargon, but at the end of the day, it's some kind of as a service, IT as a service, or you can call it cloud-based service, but it does pertain to networking. So I'm not sure if the audience yet can draw the connections between network as a service and what does it have to do with Ethernet, and maybe it doesn't. If you might want to take maybe 60 seconds each and just give us your view. Where does this fit in the broader enterprise networking domain?
I think the way we look at it at Dell, right, is it is not about the networking function here, right? It is blending the line between server, storage, and networking software and applications in the data center, outside the data center, all the way to the clients, right? And the devices and the VDI. That is, you got to package it all. And then, of course, you peel out infrastructure as a service, right? Just separating out network and just saying, hey, go, I'll give you a few of these kind of, the VM type concepts on switching. That's not how we look at it, right? It's a full end-to-end IT view.
Okay.
Storage, server, networking, software solutions.
All right. Who wants to take a?
I think where we may be seeing some of this is when you have IT departments that are really acting like a service provider. So they're offering network services, they're offering data center services for different departments, and must be able to carve out resources and have some elasticity in their ability to do this. And so you do need to worry about network virtualization. You need to think about how you enable different VMs, how you move VMs, how you provide them on demand. And then I think the point that was being made earlier about how do you manage this so that carving and management of these resources by department is simplified. So I think those are some of the examples that we see, and some of the innovations that I've talked about really help IT deliver as a service provider internally.
Let me, I know we have literally just 5 minutes left before we open it up to at least a few audience questions, and I want to get some questions taken in for sure. So let me talk to each one of you guys and start with maybe Mike. Just take 90 seconds and give us your view of where you and HP see the networking industry as a whole going and what some of the challenges might be.
So I was actually going to say something about network as a service. We're all going to do that.
Oh,
I'll weave the two together.
Well, yeah. Well, I mean, 30 seconds on the first one if you have a point.
Yeah,
sure.
Gladly to do that.
Sure.
There's two things that whenever we talk to somebody, we always hear two different points of view around networks as a service. One is it a business model, and how do I want to use it as an enterprise? And from the business model perspective, and a lot of times what it's important to is the service provider who's oftentimes delivering these managed services to the client. And on the customer side, around how they want to consume things, the dialogue is often about, we don't have any IT staff anymore. We talked to one of the world's largest entertainment companies. They have 3 direct reports who work on their payroll that are responsible for the network. And to them, they rely on their service provider. And so we actually devised a model that allows for providers to deliver any kind of a solution, whether it's data center, campus, or branch, with our broad range of portfolio, but in a unique way that allows them to gain profitability immediately. But it delivers that customer the rich services that they want. Now, one of the things that becomes really important is I need to have the leading edge capability. I need that network to be connected better to the applications. And so the thing I talked about earlier, virtual application networks, is built on our single pane of glass management. So they actually are able to get a network that is dynamically provisionable. Remember, 5 minutes to provide services for exchange on a network. That's pretty phenomenal. So those are the kind of innovations that they see valuable to them that we're enabling a service provider to deliver. Now about HP, I can sum our strategy up in one word, and that's simplification. And as we think about delivering on that strategy to customers, one of the things we think about all the time, something Bob mentioned, which helped Ethernet win over Token Ring, and that's focusing on open standards, because that ensures customers have choice and flexibility. But the innovations that we deliver based on open industry standards focus on really 3 core values, which is not just to simplify the network, but to scale it and to automate it. So that way, as customers have more and more devices, as they get more and more endpoints that are become sensors in a network almost, they have something that scales. And they can actually administer that in a more automated way, eliminate the human middleware.
All right. Who wants to go? Steve?
I'll try and say that in a more punchy way, but I agree with it. The future is all about being open. Okay, so if you're a company out there, a networking professional, you want to have choice, you want to have flexibility moving forward. So for me, it's all about working with vendors, sorry Cisco, that offer a very open platform that can integrate with anything. So to your point, integration using Chef or Puppet or Python or OpenStack, these are all really, really good things. So I think if we can optimize the underlay, and I'm not going to use the 3 letters, if we can optimize the underlay and at the same time make it an open, optimized environment, then I think everyone will win, except for Cisco, sorry. Everyone will win in the customer base.
So on that note, I'd invite Sachin to come and talk to us.
Thanks, Rohit. So I think openness and I think our participation in things like Open Daylight, our announcement of Cisco One architecture, open networking environment architecture, that where we're offering a platform development kit that supports OpenFlow as well. I think we're pretty clear that we support open standards. However, we also continue to believe that we need to innovate. And so we were the first to bring out Power over Ethernet, drive that to a standard. We brought out tag switching, drove MPLS as a standard. And so we will continue to do that and offer new Ethernet innovations that we push through the standards bodies. Now, having said that, the enterprise networking vision at Cisco is really to enable the Internet of everything. So we believe we're about connecting people, connecting clouds, and connecting things. And I do believe that IT is looking for simple, secure ways to do this that help them lower total cost of ownership. And so our strategy for this is quite simple. We're going to enable this with one management, single management platform, one policy for wired, wireless VPN for your entire access network, and one network. There is no overlay. We will offer an uncompromised user experience for wired and wireless. And as these new types of devices come on board, the new physical surveillance, smart grid, the new types of sensors that are coming on, there's going to be new requirements that we will innovate for and drive through standards at Cisco.
Great. Arpit, your 90 seconds.
All right. So first of all, let me sort of change the topic a little bit because, open is like an open-ended word, right? How many of you have attended previous net events? Just show of hands, right? So, for those of you who are in Portugal, and you may have heard me say 2012 was the year of 10 gig, right? And IDC numbers and some of the other analyst numbers show that, tremendous penetration. We are getting to critical mass. And what I'm saying now, from a Dell perspective as well, is this is the year of 40 gig, okay? And this is where we're going to see a lot more throughput coming in, necessary. And, I don't have stories from, kilobits, but I'll tell you one of the stories where, we were debugging, 2 years ago, the introduction of 40 gig technologies, right? And with our partner on the test equipments, right? And we didn't know, because of the lower latency and the speed, where the problem was, right? So I think we're getting to a point where this is one of my first challenges, to the industry, right? That Dell wants to sort of address, right? Is the ecosystem needs to step up, right? The Ethernet ecosystem needs to step up. It's not just about the silicon that goes in it. It's not about the system vendors and the infrastructure that we built, right, as our peer companies. But the optics, the QSFP pluses, the cables, the NICs, right, the test equipment, you name it. Those, and there will always be a ping pong effect. So I think we want to make sure that we pull in the ecosystem along with it. By being open, by being interoperable, that's the only way we will get to, an optimized enterprise, as we call it at Dell.
Great, thank you. Okay, we are literally out of time, so we have a couple of mics, so if somebody has a question, looks like Bob has a question.
We are honored to have such 4 fine companies here with us today. I'd like to ask a sophisticated innovation marketing question, or I hope you take it that way. Around this time of afternoon, 40 years ago, the brand Ethernet was typed on a Selectric typewriter. And there's been some debate about what the word Ethernet means. Does it mean CSMACD on thick coax? Does it mean the packet format? Ethernet is prominent in the last 50 sentences you all uttered. What does Ethernet mean to you? That is, why do you use the word Ethernet in your language? What does that word mean now?
Well, a reporter asked me a question this morning, and I said to him that for the market as a whole, Ethernet represents something of confidence. That was the one word I summed up. And I think it was the panel this morning about Ethernet or Ethernot that reminded me of this, that there's been so many challenging technologies over the years, and Ethernet has demonstrated such a level of resilience because it's adapted to how people need it to change, to go from shared media to switched media where everybody's dedicated, to be able to move to the airwaves and to move to different physical media and support higher speeds over unshielded twisted pair that people didn't think was possible. And it's that adaptability and the adherence to open standards in order to meet the end user needs in the process that it's given people confidence. And it's a word, Ethernet's a word that just kind of resembles connectivity to everybody. My parents actually know what Ethernet is because the computers I gave them, I went to HP and bought them computers at an employee discount. That's how they connect everything. They understand that. And they think that 802.11 is just wireless Ethernet. And so it's a ubiquitous word that means I'm connected, and the ether kind of gives the notion that it's over any media.
Okay, yeah. Anybody else?
Yeah, so from my perspective, right, I think it is a powerful brand that has, evolved into more of a generic statement, in marketing, right? So, we don't call, let's say, we don't call PCs Intel, right? But, the Intel processor is inside a PC, right? So that's how we have been using it as a term, right? Where you have switches with Ethernet, you got layer 2 switches, you got routers with Ethernet connectivity, both at the physical and at the protocol level. You got test equipment, you got all these devices, right? So it kind of implies a bigger thing for us, at least. It's not the specifics of, you know, the actual definition you meant, right?
Right. Do we have any other folks with a question? All right, there's one here in the middle.
It's a cheeky comment, not a question. I mean, you could call yourselves Ethernet inside everything.
Yeah, Intel wouldn't like that.
Okay.
Technically, we do at HP. By Virtual Connect in a C-class server, you got Ethernet inside. We'll start marketing it that way.
Yeah, I think all of you might want to say something inside, you know, each of our portfolios. But it's a good point. Certainly a good branding idea for sure. All right, I think with that, let me close the panel. I want to really thank the panelists for a really very, very, shall we say, debate-worthy panel. I really appreciate it. Thank you. Thank you.
Thank you, Rohit, and thank you to the panel for providing context for what we've been talking about all morning, from history to today. Are you okay there? And should we move on to the next session? I think Tam dell'oro is going to give us, hopefully, as she usually does, a blizzard of statistics as to where the market is today. Tam dell'oro, are you here? There you are. Come on down, Tam dell'oro.
It is on. Okay. Can you hear me? No? Yes. Okay. So panelists, come on stage, and I'll just start by giving you folks a little background. But before we go into the background, put my paper down. I just want us to take a reality check. All the people here that planted the seed, developed that seed of Ethernet, do you realize what great jobs you've created for people all over the world? Really? It's fantastic, fantastic what you folks have developed. Anyhow, I'm going to take about 2 or 3 minutes, and I'm going to give you a little background about Ethernet and carrier networks. I got to do this. Did that do it? No. There we go. Let's do one more. Okay, just to give you a frame of reference or a little perspective on Ethernet and carrier networks, Ethernet became popular in local area networks. Years ago, you had structured cabling. Before structured cabling, it was unstructured cabling. Do any of you guys remember that thick black coax cable above the ceiling rafters? There you are, good, thanks. I just remember the one coming down. Anyhow, and do any of you remember when token ring was bigger than Ethernet? Yeah, so we had some proprietary structured Ethernet. What this shows is shared Ethernet and token ring. We had FDDI, ATM. Does anybody remember DAISY systems? All right, and Proteon? Great. Cabletron? Yeah. Anyhow, Ethernet in enterprises was quite popular in the 90s, and then sometime around this early 90s time frame, we came to switched 10 meg Ethernet, and switched 10 meg Ethernet only lasted a couple quarters, and then bam, it went over to 100 meg Ethernet, and it's Howard's company and a couple others that just turned the whole market on its ear. Look at the scale there. It was rapidly up to like a $10 billion market. Right now, this is just Ethernet switches. All right, there's Ethernet adapters, you've got Ethernet and optical transport, you got a lot of other Ethernet. But this is the mother of Ethernet here in the LAN. And we're at about $20 billion a year. Just to show you the longevity. Now, who do I point this at? Oops. Now, just to turn to the panel here, set you guys up, Ethernet started out in carrier networks back in the early 2000 timeframe using the LAN type of equipment in the carrier networks. But then we got these carrier-style Ethernet switches and routers, and as you can see, they started replacing those frame relay ATM switches. And this is a relatively new market, and it's growing quite rapidly. New applications like LTE will probably drive it even farther. So now we're going to switch over to the panelists here, and we are going to ask them to each talk about how Ethernet is important to their business or how it's been important. And perhaps, Howard, we'll start with you. Howard co-founded 3Com and then started Grand Junction Networks, which innovated 100 gig switching or 100 meg switching. We've got Saeed over here at Juniper Networks, came from Redback, then went to Ericsson, now over at Juniper on product and technology. We've got Mark over here, who went to start Hatteras Networks and is now over at Overture. And we've got James here at Tata Communications, who is spearheading the Ethernet business at Tata. And we've got Yaeli over at Verizon, who is in product and technology on Ethernet and internetworking. So please, Howard.
Thank you, Tam. So you have to understand that Ethernet, and I know you do understand this, comes from the LAN world. And it really wasn't a carrier technology. And in fact, we fought viciously wars specifically about the physical layer. And I do understand why we did that, but now it all seems for naught. Because you remember what John Schock said earlier this morning. He said that, we don't really have carrier access anymore. We don't really have multiple stations accessing the cable at the same time. And we don't really have collisions anymore. So what do we really have? And it's an excellent observation. Because now, despite the fact that we fought those physical wars, we now only have what remains, which is the frame. The frame remains what's really valuable. And even though we did fight those wars in the standards bodies, the frame is the heart of gold. And it is the frame which allows us actually to move forward and make speed irrelevant, because if we really were attached to the physical layer, we couldn't be going to 100 gig and 400 gig and maybe a terabyte. It just wouldn't work. So what's going on right now is we are making this carrier, if you will, suitable by keeping the frame and by moving to different physical interfaces that serve our needs. I used to use this rule of thumb, which was every time we change the protocol, you're going to take a 50% performance hit. Every time. And so there's this beauty in not changing the frame. Now, whether that rule of thumb is right or not is not what's important. What is important is that carriers are in the business of selling services and making money. And if the efficiency goes down of the network, this is a bad scene. It can't work. So, by retaining the frame format, this is what's gold. And so what's happened over the years is the practice has evolved. And how has it evolved? Well, we would send Ethernet over SDH and SONET, or we would send Ethernet over IP, MPLS. And now, what the Metro Ethernet Forum stands for is we go to market with carrier-based Ethernet. We don't have to send it over something else. It's a service. And so this whole thing has evolved now, so we don't have to change the frame. And that's really, really a good thing. And so when you ask the question, is this important to us? It's really important to us because it has become the go-to-market. So I asked our people, is this a criteria, a buying criteria? It turns out, no, it isn't. And you might say, well, how could it not be if it's that important to you? It's so important, it's not a criterion. It's to get in the door. It's table stakes. If you don't have this capability, if you don't have this ability to provide these services, you just don't get to play. So it has become so integral to our business that it is synonymous with our carrier provisioning and sales.
Saeed or Mark, you want to take up
Sure,
after
I can go ahead. I think coming also back to the question that Bob asked earlier, what does it mean to Juniper? I think Ethernet for us is an enabler. It's an enabler for our business. If you look at our switching and routing business, the majority of the ports we ship today are Ethernet ports. Now, on the switching side, you probably are not too surprised because, switches, we've had the LAN wars in the 90s, and Ethernet came along and won. But I think if you look at the routing business, when we as a company built basically the first purpose-built router for the internet, we didn't necessarily think about Ethernet as the primary means of connectivity. We built it for any interface. Ethernet was just an interface that we put on our routers, like we put SONET, SDH, etc. Now, if you look at what happened in the early decade, last decade, in 2000, 2003, I remember being with customers, and every customer was asking us, talk to us about Ethernet. Talk to us about what you're going to do with Ethernet. And in the beginning, you go like, okay, well, why are everybody's talking about Ethernet? And in the old days, we used to talk about Ethernet as just an interface, and now the importance of Ethernet went up. And we were like, why? Well, we think Ethernet can help us to keep up with bandwidth growth. We think it can make it cost effective for us. We think there's now an industry, an ecosystem that has scale, and that scale we think we can reuse in the service provider business. So we went off, and actually, for us, the answer was to actually build the first Ethernet router, right? A router completely engineered for Ethernet. And it meant it was Ethernet in the design process, not at the end, we're like, okay, the router is done, what are we going to put around it? No, Ethernet was in the first step of the design process. And we talked about, we had to talk about the physical footprint, the Ethernet density, the price per port that we wanted to meet, and how we're going to be able to scale that up over time from a gig to 10 gig to 100 gig today as a kind of our density leading design criteria. So Ethernet is very important for our business, and we're very glad for all the work that has been done by a lot of people here in the last 40 years, and thank you for that.
Great, thanks, Saeed. Mark?
Really, I'd like to start where Saeed left off and talk about, as you asked, what does Ethernet mean to our business? Well, my company, Overture Networks, is in the business of providing carrier Ethernet hardware, software, and services for service providers at the metro edge. And what does that mean? That's really that last mile of connectivity to businesses and to mobile towers and to data centers. And so what's been fascinating for us and what's really important, well, let me just back up. The reason Ethernet's important to us is because it's important to our customers. And what Saeed said rings true with our customers, in that the service providers had come to us and said, we believe in Ethernet because we believe it's a way to deliver higher bandwidth at a lower cost per bit, and we can build it on a reliable ecosystem that's evolved. And what's been fascinating to watch is how Ethernet has evolved in the carrier space over these years. I mean, I remember the mid-90s when there was this thing called transparent LAN service, and hopefully some of you guys remember that. But it was really run out of a couple of cowboy-operated service providers that really thought they could get a jump on some of the incumbents by delivering really high-speed connectivity in sort of fiber-rich areas in metropolitan cities. And that evolved, from small kind of competitive operators into the major operators. I remember Bell South had a service they called Nimly, and it was an Ethernet-based service where they deployed an enterprise switch in the central office, and they put little media converters out at the edge of the network. Well, this has really taken off, obviously, and evolved, to the point where there's, millions of connections around the world in Ethernet as a service. And it's amazing because it started off as dedicated point-to-point connections, often Ethernet over SONET, but it also simultaneously became a sort of dedicated Ethernet connection out to a building. But then as branch offices needed to come online with a corporate, overriding switched Ethernet service, then technologies like Ethernet over voice-grade copper came on board. And so, we have Ethernet over bonded copper now, Ethernet over T1s and E1s, and Ethernet over the air. There's microwave Ethernet technology now. And we really are at a place where the ether can be anything. And it's an amazing time. We now have Carrier Ethernet 2.0, which has really taken Ethernet to the next level in terms of classes of service, delivering multiple classes of service, manageable, performance-assured services, and then the ability for service providers to have a standard way to interconnect with each other around the world. So, all this really drives the need for Ethernet in our business.
Thank you.
Sure.
James? Why doesn't James start off, please, by saying how he's been in that business 5 years and it's grown 15-fold?
Yeah, so I've been around longer than that, obviously, but in Tata I've been with the company for 5.5 years, and we've grown the Ethernet business by 15-fold, which is relatively simple when it's sort of single-digit millions, but it gets more interesting once you get to tens of millions, and now we're at hundreds of millions. So it's a very, very fast-growing industry. As Mark said, it's the reason why it's key to us is because it's key to our customers. And our customers are saying that Ethernet is the way that they want to do certain tasks. They don't want to do everything over Ethernet in the WAN, but they do want to do certain important tasks. And I think it's almost like the historical origins of Ethernet are coming back to support it once again. It started off in the LAN, and in fact it's the importance of the LAN today that is making it so important in the WAN. It's so important in the LAN because it's what connects together data center devices. So servers and all of those sorts of things are all, even if you're doing fancy things at a higher level, you're doing things with VXLAN or something at layer 3, you're still fundamentally plugging an RJ45 jack or whatever it might be into the back of a server. And that means that Ethernet starts all the way from the very starting point of the cloud all the way through. And if you can drive connectivity between those servers so that it stays within the same medium, within the same Ethernet frame, all the way through from end to end, then you have something that's really significant for the customer. And it comes back to a theme that's been quite frequently talked about this morning in particular, which is simplicity. The last thing that customers want to do is start layering multiple things on top of each other, and then they have competing interests from different protocols. Ethernet wants to behave in one way, IP wants to be routed in a different way, and trying to get those two things to line up. The fact that Ethernet can be used to extend data centers and make, we talked about virtualization in the previous session, virtualization of data centers starts to get very interesting. If you're virtualizing all your applications and all of your servers, then let's also talk about virtualizing your data centers so that Singapore and Hong Kong, at least from an application perspective, almost behaves the same way as if they're connected directly together on a LAN. That's quite transformational as far as a data center designer is concerned. And I suppose that the final aspect that we see is that because cloud has come on much faster than anybody expected it to do, it's grown much, much more quickly than anybody thought it would. Particularly as those of us that remember it, we had a go at it with application service providers, if you remember those. And in fact, I would argue that really cloud is a fancy version of mainframes, really, and shared access to mainframes. So we've seen this many times before, but now cloud has suddenly really taken off in a way enabled by internet and so on that's really exciting. As that happens and these environments become more and more large, Ethernet is absolutely there from the very beginning, and extending that across the WAN becomes something that customers really are interested to do.
Thank you, James. Yali, want to talk about Ethernet with Verizon?
Yeah, sure. So Verizon, as a global provider, that we definitely are there to provide whatever the services that our customer need. Ethernet is one of the fastest growing product we have seen in the last few years. And the customer require Ethernet, in our view, for, I believe, 3 reasons. One is that Ethernet provide the speed, higher speed, up to 10 gig in our case as a standard product. And number 2, it provides differentiated class of services. So it depends on the customer needs, then the customer could choose different service levels and pay different prices. And number 3 is that the customer is able to increase the demand for bandwidth dynamically. So with Ethernet, the customer could choose to up their speed from 3 meg to, say, to 10 meg or to up to a gig, and without have to change the physical interface. So with that, we have seen double-digit growth in the last few years in overall Ethernet services, growth in our product portfolio, and also from a global perspective, actually specifically outside of the US, we have seen very high adaptation of native Ethernet as access to our customers. Overall, we are able to provide over 80% of the solutions outside of the US, actually, from a local access perspective as a Ethernet. And we work with hundreds of other service providers in addition to our own metro network to provide that to our customers.
Wonderful, wonderful. Does anyone out there have any questions for the panel here? Then I'll throw out another question to you folks. And if someone does have a question, raise their hand and we'll tag you. Oh, we got 2 questions. Okay. Mike, right behind you.
I'm Alan Weisberger with IEEE. I worked on the Ethernet first mile standard somewhere around 2000 to 2003. And it took maybe 6 years after that standard was completed, 2009, for carrier Ethernet, business Ethernet, metro Ethernet services to be deployed and then to ramp up. Why did it take so long? A lot of startup companies, including the one that I was in, didn't have deep pockets. We went belly up in the interim. Why did it take so long, and what's going on now that causes that market to ramp up?
I mean, we're in an interesting situation as Tata. Our home market, or one of our home markets, we have India and South Africa as home markets. Both of them have got historically relatively poor last mile infrastructure. And from our point of view, when we looked at things like Ethernet in the first mile, it requires a copper infrastructure. If you look at India, there are 40 million copper lines in India. That's it, and it's declining. So this is for a population of around about 1.1 billion people. So that's almost unusable as a technology as far as we're concerned in a home market. Now, change that to look at an overall at a business. We're quite unique that we have a home market, but in fact 3/4 of our revenue is generated internationally. So we're all about long-haul intercontinental capacity, and we now with Ethernet services we reach 64 countries today with our own capability, and then we extend beyond that through NNIs. Every single market we go into has got different situations. Some of them have got legacy service providers who had copper infrastructure and they have implemented Ethernet in the first mile. It's an active market in France, for example. We can get good connectivity. UK, same sort of thing. But I've got an Ethernet node in Zambia. Let me tell you, there is no Ethernet in the first mile capability in Zambia. I have to buy fiber and all these sorts of things. So it really depends where you are, whether it got implemented or not, and really what the local infrastructure was that was there to support it. But for us as a service provider, as a competitive service provider, it's a huge enabler to bring large amounts of capacity to an end customer relatively inexpensively. Why did it take so long? We weren't there to push it, maybe.
Well, and maybe to add a bit to it, I think there's two dimensions. I think one is Ethernet as a service, as mentioned by James, and I think that's one dimension. The other dimension is Ethernet as a transport, right? And when you talk to service providers in those days, and we talked about, okay, we want to introduce Ethernet, then they said, that's great, we love it, but we want restoration, protection, traffic engineering, all the things that we're used to in the days of ATM, frame relay, SDH, SONET. We want to basically recreate it on Ethernet. And we had to actually come up with new technologies, new standards, and implement them, get them deployed, and that takes time. And I think that was one dimension of it. And at the same time, there was the access part and getting basically services off the ground and the local loops, et cetera. The service part is another dimension that service providers had to worry about.
Yali, I think you
I
wanted
just want to add to that. Definitely the infrastructure plays a role here. So in the case of Verizon in the US, just this year we were able to launch 120,000 new lit buildings. That's through GPON because we have the fiber network in there. So when you have the legacy copper network, then you don't get the efficiency and the customer don't get all the benefits in the last number of years. So that's why probably the uptake was slower in the past, but it will go faster. And next year we plan to launch more. Yeah.
I'd just like to speak up as a vendor of some of those Ethernet and the first mile solutions. We saw the Ethernet over copper as a piece of the overall puzzle rather than sort of the end game. And what really bolstered the growth in carrier Ethernet was the evolution of the work out of the Metro Ethernet Forum, or MEF. And that's really because those services had to be defined and standardized. And we're really actually at a point now where things are taking off like crazy, and it's partially because there's now a standard interconnect among operators. And so at the external network-to-network interface that's been defined by the MEF, it's really enabled. And I think, Yali, you were talking over lunch that this is a huge enabler for Verizon as they move outside their traditional markets. So, there's a big ecosystem component to this growth and what has taken so long, I guess.
Yeah, definitely. Just to add to that, if I can, that in order for us to interconnect with the other carriers or use that as a last mile, then we have to certify each of those carriers. So the certification and the standards defined by MEF is very important for the carriers to work together and to go through the certifications.
Next question, please. Oh, we got two more. Yeah.
Yeah, hi. Okay, so what do you think is holding back Ethernet the most from all of you, please?
Well, I mean, holding it back in comparison to what, I suppose?
So what I would say is that people are still choosing TDM technology, SONET, DS1, DS3, even when Ethernet is available. And that means something is holding back people from buying Ethernet where they could. So what do you see is getting people to make the decisions to use legacy technologies even where Ethernet is available?
Human nature, I don't want to change.
Yeah, let me. So I asked our people what percentage of all the interfaces that we ship are Ethernet. 98 plus. So I think the reality of your question is suspect. It's almost entirely Ethernet. Where there is a legacy solution, some carriers running over SDH or SONET, they may continue to do that. But the new shipments are not just a small percentage Ethernet, and it's Ethernet in different forms. It's 10 gig, it's 1 gig, it's 100 gig, but it's Ethernet. It's that frame format. So no, I think your question is incorrect. It's overwhelmingly Ethernet.
I think just to add, I think if there's one thing where we've been held back and we're now moving forward, it's the wireless part, the mobile backhaul. I think when you look at standards like 2G and 3G, they were not really optimized around packets. And I think when LTE came around, it is completely IP optimized for packets, Ethernet. So, and I think a lot of operators are migrating. So if you look at, for instance, where a lot of these DS3s have been deployed, it's been to base stations around the world to basically maintain the service on 2G and 3G. And that right now, I think in the last few years has been accelerating. And if you look at mobile backhaul solutions and vendors, it's a very, very interesting market right now.
Also, in my view, some countries, the pricing makes a difference as well. For example, in Canada, the Ethernet price for 2 meg or 4 meg is higher than, or 3 meg is higher than a T1 or 2 T1s. So the pricing plays a role here as well. And that's basically, I see that in North America, and amazingly, not so much outside of North America.
Good answer. Good. One more question here.
Do you see SDN like Nurgens? Or network with SDN, do you see them like that? Like a big evolution or a very important evolution for you?
Is SDN an important evolution for carrier Ethernet?
Absolutely. Well, I think that it's interesting because Ethernet is a protocol that's evolved without a control plane. So there are various ways to control and manage Ethernet and native Ethernet services, but usually it's inserted into something which in turn has a control plane like MPLS. SDN brings the possibility to have a native transport layer in Ethernet that is controlled by a higher order control plane. And I think that's an interesting innovation, and it's something that even as a carrier we haven't fully thought through what the implications of that are. But perhaps you could say that if an Ethernet frame originates from the back of a server and it can be transported all the way across the WAN as an Ethernet frame, and you could have a single unified control plane that took it all the way from the back of that server all the way across the world to another location, that's a very significant evolution, and we need to understand what the implications are of that. I think something else we see within SDN from a carrier point of view is, and again this is something that we're still thinking about what the impact of it is going to be, SDN has got the potential to flatten the network economics model. Before we used to build networks to meet a particular price point. So we might build a network or an offering or something to produce something that's very, very low cost, like for internet transport, for internet transit, for example. So we carry 4,500 petabits of traffic on internet every month over our network. In fact, using Juniper equipment. We could not afford to do that if we had many, many, many layers of complexity that sat within it. On the other hand, the services we provide on private MPLS or WAN Ethernet services have complexity in traffic engineering and latency concerns and class of service and prioritization and latency, strict latency controls, failover and all that sort of thing that needs to be controlled and managed, and that's very expensive. If you're saying 5 years from now, everything will have a common transport layer and there'll be a common control plane and routing layer, then that says everything costs the same. And as a carrier, we haven't thought through what the implications are of that. It costs exactly the same for me to carry an internet piece of traffic of somebody browsing YouTube as it does to carry a trade against the New York Stock Exchange. What implication does that have? We still need to think.
Thank you. So I'm going to say thank you, panelists. We've run out of time, and I would say press people, go nab them during the cocktail sessions, okay? And ask them questions because they would love to talk to you. Thank you.
Thank you, Tam.
Thank you.
All right, thank you.
Okay, great job. Thank you very much. And I think we're going to have a quick break for refreshments and see you back here in Oh, can we make it about 20 minutes or so?